Day 37, number 9, defining oxidation. Well, oxidation would be the loss of the electron. All right, loss of electron, the reduction, gain of the electron. Now, oxidation, usually you can gain oxygen or lose hydrogen, and reduction, you can lose oxygen or gain hydrogen, and those are usually reductions. But we're just going to keep it with loss and gain of electrons. All right, the oxidation number rules. So when we do this, what are the rules? Well, number 1, an element by itself is equal to 0. All right, 2, monatomic ion equals the charge of the ion. All right, because it's one atom that's a charge, one atom that's a charge. 3, fluorine is -1 in compounds. Number 4, oxygen is -2 in compounds. Except OF2, O2 minus, O2, 2 minus. Number 5, the rest of the halogens are -1 in compounds, except when paired with fluorine or oxygen. So basically, if it's a central atom, right? If ClBrI are a central atom, they're not going to be -1. 6, hydrogen is +1 in compounds with non-metals, and it can be -1 when paired with a metal. And finally, number 7, group 1 is +1, group 2 is +2 in compounds, always. So those are your 7 rules that we'll have, all right? And again, if it's not on the rule, the more electronegative atom usually gets the preferred charge, all right? All right. So let's do some oxidation numbers here for number 12. Again, we're going to have the math help on the bottom. All right, and let's see here. We do A for chloric acid, -2 for oxygen. That's a -8. Now, chlorine's next, right? And it can be -1. But the problem is if I make chlorine -1, then all of a sudden chlorine makes that -9. Hydrogen would have to be +9. That's just not possible. Hydrogen only has 1 proton. So at the most hydrogen can be is +1. Right? Technically it can be more negative, but it can't be more than +1 because it's a proton. So hydrogen's going to be +1 because with nonmetals, +1, +7 for chlorine. And chlorine's in the center, right? So it's in the center of that. These ternary oxyacids, H is actually connected to the oxygen, even though it's written before the, looks like it's close to the chlorine, but it's actually on the oxygen. So there, chlorine is a central atom. B, Phosphate, -3. Oxygen is -2. There's 4 of them, so that's a -8 plus 5. Bromate, we add up to -1. Oxygen is -2. -6, that means it has to be plus 5. Dichromate, equal -2. Oxygen is -2 times 7, -14, plus 14. So chromium is plus 6. E. Now E, if I just name E, I get the answer, right? Fe2O3, iron 3 oxide. -2 plus 3. Does it work? Yes. O2. O2. Very easy to write down -2 here, but it's an element by itself, so it's 0. Iron 3 plus is just plus 3. Sodium hydride. Sodium hydride. Sodium's plus 1, so it means -1, and it works. Calcium nitrate. Now we add up to 0. Oxygen's -2, and that's a -6. -12. Calcium's plus 2, which is plus 2. And so we would have plus 10 on the bottom, which means this is plus 5. And I did this with the wrong color. Let's try this again. Plus 2 plus 10 minus 12. Now, if we wanted to, I could take nitrate out and just do nitrate. So -6 plus 5 plus 5. All right. Whoa. Sorry about that. J, nickel 2 oxide. All right, it's pretty straightforward. Some of these binary, again, the binary ionics should be straightforward. Just like this one, K should be straightforward too, because you see sulfate. You know sulfate overall is -2, all right, because you know your polyatomic ions. And so if there's 2 -2s, that means sulfate has to be plus 4. But let's say you didn't know that. SO4 2 minus. Oxygen would be -2, -8, plus 6. Sulfur's plus 6. Plus 6, -2, and 2 of them. Let's see how we do. So that's 8 and 2 is -16, plus 12, and plus 4. And 4 plus 14 is, well, I can't do math right now. What is 6 times 2, everybody? Let's go with 12. All right, usually 6 times 2 is 12. All right, so there we go. It does work out to be 0. And finally, oxygen difluoride. Fluorine's -1. So oxygen has to be plus 2. All right. Number 13. The last one, which is probably good for me. In the redox equation below, list the element oxidized. So we are listing who's oxidized, who's reduced, and the change. All right, so oxidation states. Oxidation states here. So let's get this through. We see we have to do oxidation numbers. So manganese permanganate, we know oxygen's -2. That's a -8. So there has to be a plus 7 for manganese there. Oxalic acid, 0, -2, plus 1. So it looks like carbon is at plus 3 each, plus 6 underneath, plus 3 each, plus 1. CO2, I have -2, so that's -4 plus 4 plus 4 plus 2, and -2 minus 2 plus 2 plus 1. All right, who changes here? I got manganese changes. I got carbon changing. All right, so somebody is oxidized and somebody is reduced. So in this situation, if I need to go, okay, manganese has 25 protons and 25 protons. Now, 7 plus means I have 7 less negatives than I do positives. This means I would have 18 negatives, and if I added 18 and 7, I should get 25. Works. Here I have 23 negatives for manganese 2, right? Because if I add 2 to 23, I should get 25, and that works out beautiful. All right, so who's gaining electrons? Well, it looks like carbon lost one. It looks like manganese gained them, right? So Mn goes from 7 plus to Mn 2 plus. That's a gain of electrons, right? Which is reduced. And then oxidized, I have carbon 3 plus going to carbon 4 plus. That's oxidized. All right. And so all I want for there is just what's the change. I don't need how many electrons. We're not actually balancing them like that. That's more Chem 2. This is all I would want, is who's oxidized, who's reduced, where the electrons going to and where are they coming from. And that is